Hey guys, so I wanted to record just a super quick little thing for you about polarity. I know some of us are still struggling, so I'm hoping that this will help. The goals of this short little PowerPoint is that you understand what polarity means, that you're able to explain that certain atoms are going to have more pull on electrons depending on those atoms' properties, that you will be able to identify molecules as either polar or nonpolar, largely based on symmetry, and also that you can identify some of the geometries that tend to be polar molecules. So polarity is when you have bonds where the electrons are not shared equally. The atom that is more electronegative, and remember the big electronegative atoms are things like oxygen, nitrogen, fluorine, chlorine. So the atom that is more electronegative will hog the electrons. It'll pull them closer to itself. And when that happens, that creates an area on the molecule that has a slightly negative charge where all those electrons are. In general, whenever you have two atoms involved in a bond that are different, they're going to have a different pull on those electrons. So let's look at an example. Hydrogen fluoride is not a very good Lewis structure, but there we go. There's hydrogen fluoride. And the electrons that are shared between that hydrogen and fluorine are held closer to fluorine because fluorine is much more electronegative than hydrogen is. So because of that, because the electrons hang out around fluorine versus hydrogen, that makes the fluorine side of that bond slightly negative charge and the hydrogen side of that bond a slightly positive charge. We call that a dipole. A dipole is any time you have charged areas within a molecule. So a polar bond can create a dipole. Nonpolar bonds are when electrons are shared equally between the two atoms. And in general, whenever you have two atoms that are the same, they're going to have the exact same pull on those electrons because they have the same electronegativity value. So that would be a nonpolar bond. Another bond that is always going to be nonpolar because their electronegativity values are very close is the carbon-hydrogen bond. Looking at a couple examples, anytime you have two atoms that are exactly the same, those are going to be nonpolar because they have the same electronegativity values, so the electrons are distributed evenly between that bond. Also, if you have something like carbon tetrachloride or CCl4, this is also a nonpolar molecule. And the reason that one is nonpolar is that all the atoms that surround that carbon are the same. Therefore, the electrons end up being distributed equally all throughout the molecule. So there's no area of the molecule that ends up with a slight negative charge because those electrons are all evenly distributed. So how can you tell in general if a molecule is polar or nonpolar? Well, to know specifically, you can look at the electronegativity differences between the atoms. But that's not such a practical way to quickly be able to tell if a molecule is going to be polar or nonpolar. So there's some quick general rules that you can use. The first is that if you have different atoms around a central atom, that will always create a polar molecule. The second is that if you have the same atoms around a central atom, that will always be a nonpolar molecule. So let's look at some examples. If I have H2 diatomic hydrogen versus hydrogen fluoride, those two look like that. The H2 diatomic hydrogen is nonpolar. Hydrogen fluoride is polar, and again it's polar because those are two different things. Looking at other examples, carbon dioxide versus a compound containing carbon, oxygen, and sulfur, carbon dioxide is nonpolar, and it's nonpolar because everything around that central atom is the same. The molecule that has carbon, oxygen, and sulfur is polar, and it's polar because everything on that central atom is not the same. Oxygen and sulfur are not the same. Looking at a couple more examples, we have H2O and ammonia, so water and ammonia. Both of these compounds are actually polar, and the reason why they're polar is that we need to treat any unshared pairs of electrons on the central atom as something different. So if we were to look at oxygen, the central atom is, if we were to look at water, the central atom is oxygen, and it has two hydrogens and two lone pairs around that central oxygen, so those things are not the same, making it polar. If we were to look at ammonia, NH3, That central atom, the nitrogen, has 3 hydrogens and 1 lone pair on it. Those things are not the same, so that makes it polar. Looking at methane, CH4, and CH3Cl, the CH4 methane is nonpolar. It's nonpolar because a couple of reasons. One, it's evenly distributed. There's the same thing around the central atom. It's a carbon with 4 hydrogens on it. So those are all the same, and we say it's nonpolar. But it's also nonpolar because the carbon-hydrogen electronegativity difference is very small. So that bond is always nonpolar. If we look at CH3Cl, that is polar, and it's polar because those things around the central carbon there are not all the same. There's 3 hydrogens and 1 chlorine. The final example here is a molecule that looks like this. This one is also going to be polar, and it's polar because if we look at the atoms attached to that central atom, we would see that those things are not the same. In general, this shape that we have here, the planar shape, in general, that planar shape ends up being polar all the time, although there certainly are some exceptions to that rule. Okay, that was a quick and dirty little explanation about polar molecules. Remember, the only thing that I would want to remind you is that a molecule can have polar bonds. For example, that CO2 molecule, the carbon-oxygen bond is polar, but because there's one on either side of the central atom, that makes the molecule itself not polar because those two things cancel each other out. Okay, there you go.